Hey guys, welcome back to another lesson. Today we are going to wrap up with a nice little bow everything that we've been talking about so far with polynomials. So it's mainly old material. There's one little new thing that we'll talk about, but you guys know most of this content already. And it's important for you to watch this because really pay attention to the things that I'm saying and what I'm doing, because on your next day of class, you guys are going to be doing a project that's very similar to this. So I'm basically modeling for you what I would expect to see. So I am going to take you through factoring a polynomial and kind of identifying all the roots, everything that we know, and everything that we can tell from the different forms of the polynomial. So our first example here is y equals x to the fourth minus x to the third minus 5x squared plus 3x plus 6, okay? So you guys already know how to determine the degree. The degree, just a refresher, is the highest exponent. The highest exponent is 4, because x to the fourth is the highest exponent that I see. 4 is an even number, so it's an even polynomial, which means that the end behavior will be the same. So they're either going to both be going up, both of the ends of the polynomial are both going to end going up, or they will both end by going down. All right, now my a value. The a value is my leading coefficient when I have it in standard form. As I look at my polynomial here, I don't actually have a leading coefficient written in, which automatically tells me that it's like an imaginary 1, right? If you don't have anything written in, it's like there's a 1, an invisible little 1 there, because anything times 1 is itself. So my a value is 1, which is a positive number, which tells me that the right side of my graph is going to be going up, okay? That leading coefficient always tells me what's happening on the right side of my graph. On the right side of my graph, it's going up. Then, since both ends of my polynomial are going to be ending in the same direction, the left side will also be going up, okay? That's step 1, just identifying all that different information from my polynomial written in standard form, which is given to me. All right, so step 2 is to graph the polynomial in your calculator and sketch it below. So there is a calculator app that I have given you guys the link to. I already typed it in here just to make it a little bit easier, so you didn't have to sit and watch me typing everything in. So that top equation is my polynomial, and I am going to take a look at its graph. Okay, so here's what it looks like. All right, so it's a little bit difficult for me to tell what we've got going on here, so I'm just going to zoom in a little bit on my window. I'm going to set my x min as -5, x max is +5, scale is 1, fine. Y minimum I'll make -3. Y max I can keep the same, okay? And I'm just kind of doing this because now as I look here, I can get a good zoom in. Okay, so as I look at this graph, I can see, and actually I might even want to zoom in a little bit more. I'm going to zoom in. Let me see here. I'm going to make my x min -3 and my x max 3. Okay, because now I can zoom in a little bit more. What I'm looking at is for my roots. I'm looking for where it exactly hits the x-axis. And I can see here from this picture that there are 2 places where it hits at an integer value, right? Right over, actually, let me recreate this sketch back on my document. Okay, so as you can see, this is a pretty rough sketch, but here's kind of some of the things that I thought about as I was sketching this. I noted where my x-intercepts were, what my end behavior was, kind of where my y-intercept was, and that the kind of like dropping point, that lowest point, on the left is a little bit lower than the one on the right, right? You can flip back and forth, and it's not perfect, but it looks pretty good, okay? So a couple things that I can identify as I look at this graph that's on my graphing calculator, I can see at -1, I have a root, and at +2, I have a root, okay? And I can just see those on the graph. So my next step that I want to take is I want to identify where those roots are. So I can see right here, right there at -1, I had a root. And then right here at +2, I had a root. Okay, so I graphed my polynomial in my calculator. I sketched it below. It's a rough sketch, but it's not that rough, like I thought about it a little bit. And then I identified my integer x-intercepts at -1 and 2. So now I have to use those integer x-intercepts to write factors of my equation. So I have these roots. My roots are at x equals -1 and x equals a +2, okay? So you guys have gone from factors to roots, but now we're going backwards, right? So if I had the factor like x -7, that would tell me I have a root at +7. So I'm going to use these two roots that I just found using my calculator to identify that I have a factor at x + 1. The root is x equals -1. The factor is x + 1, right? X equals 2. That root tells me that I have a factor at x - 2. You're just taking the opposite of what the root is, okay? So in your last lesson, we talked about PolyDoku. And in that lesson, we were just teaching you about PolyDoku. And so we told you what the actual factors were. We filled in the PolyDoku for you. Now you guys have already learned about PolyDoku, and you are going to be filling it out on your own. So I'm going to take my first factor, and I'm just going to take x + 1. That's a plus. Okay. And I fill it in my PolyDoku box. Then I am going to take my original polynomial, and I am going to fill it in along the bottom. So I've got x to the 4th plus 3x to the 3rd, or it was just +3. What was it? Let me look. It's minus. Okay, good job, Leverson. Nice work. Minus x to the 3rd minus 5x squared plus 3x plus 6. Okay, great. So plus 3x plus 6. Now, if you want to take a minute right now and try to do this PolyDoku on your own, pause the video. Otherwise, I'm going to give you a little bit of a refresher. So start by taking your first term in what you've got written along the bottom and place it in this box in the top left. So that will be, that will be x to the 4th. Now I have to think to myself, x times what gives me x to the 4th, and that goes up here. X to the 3rd times x gives me x to the 4th. So it goes there. Then I multiply down. X to the 3rd times a +1 gives me x to the 3rd. Now, I know that -x to the 3rd is the sum of the two blanks right here. So -x to the 3rd is the sum of x to the 3rd plus some number. What does that number have to be? It has to be -2x to the 3rd. Okay, so now I have to think to myself, x times what gives me -2x to the 3rd? That has to be -2x squared. And then I multiply down, so -2x squared goes right there. -2x squared times a +1 gives me that. Then keep working my way over. I am going to say, okay, -5x squared is the sum of -2x squared and something. What does that something have to be? Okay, well, it has to be -3x squared. So now what times x gives me negative 3x squared? That has to be negative 3x. Multiply down, negative 3x times a positive 1 is negative 3x. Now, a positive 3x is the sum of negative 3x and something. What does that something have to be? Well, that something would have to be a positive 6x. Okay, so then I'm going to say x times what gives me 6x. So that's a positive 6. And then multiply down, positive 6 times positive 1 gives me another positive 6, which is a match. Okay, so far so good. Okay, my last term, that constant matches up. That's how I can check my work. Right now, what I want you to do is try this next one on your own. Or I guess I'll get it set up for you guys, okay? Because this is still a little bit new. So I am going to take this number that I got up here, or this expression that I got up here, okay? And that is now going to go along the bottom. So I'm going to say x to the third minus 2x squared minus 3x plus 6. I don't need this last comment, or this last column. And I am going to go ahead and write in my other factor, which is x minus 2. So x minus 2 goes right here. All right, so try this one on your own. Okay, so take a minute to check your work right now. You should have that column of zeros in the middle. That last number should match. Once again, it's a positive 6. And then, let me see here. I just actually took my roots, or not my roots. I took my factors that I found and I just wrote them out. So this first factor that you've got, oopsies, this x plus 1, that's where I got this. Then I had x minus 2. Those are, again, from step 2 in graphing. I've got that here. And then this x squared minus 3, that's what I've got right here. Okay, so I'm breaking this equation down as much as possible. Now, I need to find all of the roots, okay? So I already know my first, oopsies, that's not what I wanted. I already know that my first factor gives me a root at x equals negative 1. My second one gives me a root at x equals 2. Okay, now I have to figure out this x squared minus 3. Where are my other roots? Well, I would say x squared minus 3 equals 0, which tells me that x squared equals 3, which means that x is equal to plus or minus the square root of 3. Okay, so there are actually 4 roots right here. X equals negative 1, there we go. X equals positive 2, there we go. The square root of 3, let me see. The square root of 3 is equal to 1.7-ish, okay, approximately 1.7. So at positive 1.7, I've got a root, and at negative 1.7, I've got a root. And if I go back to my graph, that's what these two numbers, or what these two roots are that I couldn't see. It's because they're decimal values. They're not exact integers, okay? So that's where I got those. All right, let's go on to the second one. Now, what I'm going to do is I'm going to ask you to pause the video right now and try step 1 on your own. Okay, so check your work. The degree is 4. That's the highest exponent, which is even, which means that the end behavior is going to be the same. My a value is 6. That's positive, which means my right side is going to go up. Since they're going in the same way, both of them are going up. Okay, so once again, I have already entered this into my graph, this equation into my graph, or into my calculator, sorry. So now I had changed my window when I was looking at that first polynomial. So let's take a look at what it looks like. So with the window that I had set, this is what I get. And that doesn't really work for me, right? That's not what I want. So I have a couple options here. What I'm going to start with is I'm going to hit zoom, and I'm going to hit 6. Zoom 6 gets me back to a standard viewing window. Okay, so actually when I look at this, that's not quite great. That's not what I need. So I'm going to once again change my window. I need to go down a little bit lower. So let's see here. If I change my window, my Y minimum, I am going to go to, let's say, negative 20. Let's see how that works out for me. Okay, I still can't see the bottom, so I'm just going to play around a little bit more. I'm going to go to -40 because it looks like I need a fair amount of space to go. And now just because it's such a big range, I'm going to change my Y scale to go by 5s. Okay, still not quite there. I'm going to go a little bit lower. Okay, since I'm only graphing a rough sketch, well, let's see here. I'll go a little bit lower even yet. Okay, now I'm just missing a little bit of that, but that's okay. Since I'm just doing a rough sketch, that's fine. And once again, I can see my integer values. I've got 2 integer values that I'm looking at here at -3 and at +2. So I am going to go back here and I am going to graph these. Okay, once again, you see my sketch. It's not perfect, as you guys know, but it's okay. I can figure it out. Okay, so now I'm going to mark where my integer x-intercepts are. So that's at -3 and at +2, which gives me the factors of x plus 3 and x minus 2. Once again, I'm just taking the opposite, okay? Now I'm going to go ahead and divide using PolyDoku. So let's start by setting myself up. Okay, I'm going to use x plus 3, and then I'm going to write out this full polynomial right below. Okay, so I got you started here. I wrote in the full polynomial along the bottom, and I wrote in that first term there. What I want you guys to do right now, pause the video, see if you can do this on your own. Okay, I think you guys can, right? Thanks. 6x to the 4th. X times what gives me 6x to the 4th? Try it. Okay, so go ahead and check your work right now. You should have gotten the answer along the top of 6x to the 3rd minus 11x squared minus 3x plus 2. You got those 6's to match. I went ahead and started the next PolyDoku puzzle for you, and I want you to once again try it out on your own right now. Okay, so go ahead and check your work right there. You should have broken it down and gotten 6x squared plus 1x minus 1. Now, step 6, write the original function in factored form and then find all the roots. Okay, so my factors that I found were this x plus 3 for my first PolyDoku puzzle, and then I had x minus 2 from my second PolyDoku puzzle, and then from my second PolyDoku puzzle also I've got 6x squared plus 1x minus 1. Okay, so from here, I can jump right in and I can find 2 of my roots, right? So this first factor tells me that I've got a root at x equals -3. Second one tells me I've got a root at x equals 2. And this third guy, well, that's a quadratic. Luckily, I know how to factor quadratics. So let's do this. Okay, first I'm going to take 6x squared. So 6 times -1 gives me -6. I'm going to write that on the top. At the bottom, I'm going to write in my +1 for my middle term. What 2 numbers multiply to give you -6 and add to give you a +1? Well, that would have to be a +3 and a -2. And then I draw in my dashed line, and I need to divide by that 6 since that's my leading coefficient. So divide by 6. This guy simplifies to 1/2, and I can't have the 2 in the denominator, so I bring it out front. Okay, so when I'm factoring this, that gives me 2x plus 1, because I take this 2 from my denominator and I bring it out front of my x, and then the +1 stays there. Then I'm going to take this -2, also divide it by 6. That simplifies to -1/3. And once again, I can't have that denominator, so my other factor is 3x minus 1. Okay, so I've got my quadratic here in factored form. I factored it. So exciting. And I'm going to use these two factors to find my other two roots. So I've got 2x plus 1, set that equal to 0. Subtract the 1 would give me 2x equals 1. Divide by 2, x is equal to 1/2. Next, 3x minus 1 equals 0. 3x equals 0. 3x equals 1. My bad. What was I thinking? 3x equals 1. And then I divide that by 3. So x is equal to 1/3. Also, I just noticed a mistake in this other factor. When I subtract the 1, I get negative. So this is a negative 1/2. Okay, so I've got these 4 roots. I've got a root at x equals -3, a root at x equals 2, a root at x equals negative 1/2, and a root at x equals 1/3. Okay, so I would recommend that you check your email for your polynomial. Everyone in the class is going to get a different one where they're going to have to follow the same process. Check the 8.6 project. You may want to start working on that. It is not due until the Tuesday the 26th for third hour and Wednesday the 27th for second hour. So you guys might want to start taking a look at that now. Email me if you have any questions. You're going to be making it on Flipgrid, which will open up right from Canvas from the link into the assignment. You will have a regular assignment on those days as well. You just need to submit then. So you want to get started working on it as soon as possible. And if you have any questions, feel free to email me. All right. Bye, guys. Have a great night.